Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and in this video we are going to solve another GATE question. So this GATE question was asked in the year 2012 for 1 mark, and this question is related to the fork system call. So let's see this question. So the question goes something like this. A process executes the code. This is the very simple code snippet that has been given. All it has is 3 fork statements, right? And the question is asking that the total number of child processes created is, your options are 3, 4, 7, and 8. So as we already know, there are several questions like this that have been asked in the GATE exam related to the fork question. So what they ask is almost the same. They just give a piece of code where it has some number of fork statements. And the most asked question related to the fork system call is that they will ask that, given a program with these many fork statements, tell us how many child processes or new processes will be created in the system, right? So we have already derived the formula that can be used to solve this problem. Before I go to the formula, let me just quickly talk about the fork system call so that you have a context. So the fork system call is used in the Unix operating system to create a new process. And how does it work? So the way it works is that when a process invokes the fork system call, the operating system creates a copy of the calling process, basically duplicates the original process to create a new process. So this is a very brief example, a brief recall of how the fork system call works. I have already discussed this in great detail in one of the videos. So here you can see there is a process, that is process A, and somewhere in the code of the process A there is a invocation to the fork system call, right? So you can see the code flow goes something like this. When the fork system call is invoked, the control is immediately transferred to the fork routine inside the operating system. Like any other system call, the control is transferred to the operating system routine. And what does the fork system call do? It basically creates a clone or a copy of process A. So this process B that you see, this is a copy of process A. So process B has been created by duplicating process A. Everything in process A remains the same. That is the code that is being executed, the data that will be processed. Almost everything is same except for a few little things like the process ID, right? So this is how a new process is created. And when the fork routine is done, it returns in both the parent as well as the child process. So this is how the fork system call works at a very high level. Now, as we know, we already have the formula for the problem that we're trying to solve. So the rule is this. So I have derived this formula in another video. I'm not going to derive the formula again here. I have already derived this formula in the video that I have attached. So the rule is that if there are n calls to fork, so read this as if there are n fork statements in your piece of code, then the number of child processes that will be created is 2 raised to the power n minus 1. uh, so basically it is like, if you write a piece of code that has n fork statements, for example in this question we have 3 fork statements, n could be any number, right? If your code has n fork statements, then the number of child processes or the number of times the fork system call will be invoked, that is equal to 2 raised to the power n minus 1. So if the value of n is 3, then the answer is 7, right? So as you can see, we can also execute this piece of code and derive at this number, that is 7. So this is the simple code snippet which has 3 fork statements. Let's say we have a parent process, and n will be the number of times the number of fork statements that we have executed, right? So we'll just count the number of child processes that we have. So let's start. After the first fork system call, we'll have a new child process, right? So basically after the first system call is done, when n is equals to 1, the number of child processes that we have in the system is 1. After the second fork system call is executed, both of these processes will again create new processes. So we'll have a total of 4 processes in the system, out of which one is the parent process. So the number of child processes is 4 minus 1, which is 3, right? And now all of these 4 processes will start their execution and basically resume their execution or start their execution at this last fork statement, and all of them will fork and create 4 new processes. So 4 plus 4, we'll have total 8 processes in the system. And if we leave the parent process, then the number of child processes that we have is 7. So this is how either you can execute this piece of code, or you can directly use the formula that we have derived to come up with the answer, right? So the answer to this question is 7. So this is the code snippet that we had. We had 3 fork statements, and the total number of child processes created is 7. 2 raised to the power 3 is 8 minus 1 is 7. You can either directly use the formula, or you can execute it yourself and come up with this number. So guys, this was it for this video. A pretty simple, straightforward question. So questions that are related to fork, as I said, are very simple in nature. All they ask is that the pattern that have been observed in the previous year question is that they give a code with a certain number of fork statements, and then they ask the number of child processes that is created. So guys, this was it for this video. Thank you very much for watching. I'll see you in the next video. Thank you.